Morning students, a warm welcome to all of you in this lecture. Today we are going to learn about the softening process of hard water. There are the number of softening process. The first method is lime soda process, second is zeolite process, and the third one is ion exchange process. So today we are going to learn about this zeolite process, how we can convert the hard water into soft water by using zeolite process. Zeolite process. The zeolite method is also called as a permuted method. The meaning of the zeolite is boiling stone, and the zeolites are, we can say the zeolites are hydrated sodium alumina silicate. The general structure of this zeolite is, the general structure of zeolite is Na2O, Al2O3, X SiO2 and Y H2O. So we can say it's a hydrated sodium alumina silicate. Here the X is equal to 2 to 10 and Y is equal to 2 to 6. So why we are using this zeolite in softening process? Because the zeolites are capable to exchange the Na plus ion with Ca2 plus and Mg2 plus which are present in hard water. The next point is types of zeolite. So there are two types of zeolite we can use. The first type is natural zeolite and second type is synthetic zeolite. The natural zeolites are non-porous in nature and synthetic zeolites are porous in nature and more capable to exchange the Ca2 plus ion and Mg2 plus ion from the water. Now let us see the function of this zeolite softener. Here a cylinder of zeolite softener. This is a cylinder in which the zeolite bed is fixed. It's a zeolite bed which is fixed in this cylinder. Again here we can see a layer of gravels. So here a layer of gravels, then the outlet to remove the soft water. This is a soft water outlet. Here the inlet to feed the hard water in which the number of Ca2 plus ions and Mg2 plus ions are present. Here the another outlet is given to sink. Okay. So this is the zeolite softener in which the zeolite bed is fixed. And what is zeolite? Zeolite is hydrated sodium alumina silicate, and the general formula of this soft zeolite is Na2O, Al2O3, X SiO2 and Y H2O. So this zeolite is fixed here in this zeolite bed, and under this zeolite bed again there is a layer of a gravels. When we feed the water, hard water from this inlet, when this water is percolated through this zeolite is capable to exchange the Na plus ion with Ca2 plus ion and Mg2 plus ion. The zeolite retain the Ca2 plus ion and Mg2 plus ion from the hard water. The reactions are taking place in between the zeolite and hardness causing salt. So let us see the reaction which taking place in this cylinder. So the reactions Suppose temporary hardness causing salt is present in water. So the temporary hardness causing salt like calcium bicarbonate, magnesium bicarbonate. So I am taking here example Na2Ze. So instead of this structure I am writing here Na2Ze. Na2Ze means sodium zeolite. This sodium zeolite, calcium bicarbonate. This calcium bicarbonate is a temporary hardness causing salt which present in hard water. When the hard water containing this calcium bicarbonate and percolated through this zeolite bed, the reaction take place in between this sodium zeolite and calcium bicarbonate. It form this sodium zeolite retain this Ca2 plus ion and form calcium zeolite plus twice NaHCO3. Again we can see if magnesium bicarbonate is present in hard water. So the next reaction, magnesium bicarbonate present in water, and when react with this sodium zeolite, it form MgZe, magnesium zeolite plus twice NaHCO3. Now both are the temporary hardness causing salt. Now takes the example of permanent hardness causing salt, because temporary as well as the permanent hardness causing salts are present in water. So the next reaction, Na2Ze plus MgSO4. MgSO4 is permanent hardness causing salt. It forms again sodium zeolite retain the Mg2 plus, it form MgZe, magnesium zeolite plus Na2SO4. Another reaction is Na2Ze. If CaCl2 is present, CaCl2 is also permanent hardness causing salt. If this salt is present in hard water, then the reaction is take place CaCl2 plus sodium zeolite, it form calcium zeolite plus twice NaCl. In this way, these reactions are take place in between the hardness causing salt and sodium zeolite. So in the first reaction we can see the sodium zeolites, it react with this calcium bicarbonate and it forms the calcium zeolite. Now here we can see the sodium zeolite get converted into calcium zeolite. So this is called as a exhausted zeolite. In second reaction again magnesium bicarbonate is present in hard water. When it react with this sodium zeolite, it form magnesium zeolite, means it is a exhausted zeolite plus twice NaCO3. Then Na2Ze plus MgSO4. MgSO4 is a permanent hardness causing salt. It forms magnesium zeolite Na2SO4. In next reaction you can see CaCl2. CaCl2 is also permanent hardness causing salt. It's again react with this Na2Ze and it form calcium zeolite plus twice NaCl. So in this reaction we can see the formation of the exhausted zeolite. After some time this exhausted, because of the formation of the exhausted zeolite, the functioning of that zeolite bed is completely stopped. So the regeneration is very important for the purification of, for the softening of the water, for the converting of the hard water into the soft water. The regeneration is very essential here. So for that we can use concentrated 10% NaCl solution for the regeneration. So the next part is, here we can see the regeneration reaction. Hard water is passes hard water is passes through this zeolite bed. Here formation of exhausted calcium zeolite and magnesium zeolite, and the number of ions, here the formation of these ions, all these ions are present in a soft water. That soft water we can remove from this outlet. So here the soft water outlet is given. Now regeneration of zeolite bed. The next part is regeneration part. So in this regeneration part we require 10% brine solution. 10% brine solution. So here the storage tank for 10% brine solution. Here the injector to inject, and this brine solution is passes through this inlet in zeolite softener. So in this zeolite softener, for the regeneration of the zeolite softener, we can use this 10% brine solution. This 10% brine solution is injected from this outlet, from this inlet, and the reactions take place in between exhausted zeolite and 10% brine solution. So let's see the reactions of the regeneration of sodium zeolite. Regeneration reactions. Regeneration reactions. Now in the previous reaction we can see formation of calcium zeolite and magnesium zeolites. They are called as a exhausted zeolite. So our aim is convert this calcium and magnesium zeolite into sodium zeolite, and for that we are using this 10% NaCl solution. So calcium zeolite plus twice NaCl solution. Here formation of Na2Ze, regenerated zeolite, plus it forms CaCl2. The another reaction is magnesium zeolite. It also exhausted zeolite. It can be regenerated by using this brine solution. It forms Na2Ze plus MgCl2 plus MgCl2. So after formation of CaCl2 and MgCl2, we can discard this MgCl2 and CaCl2 to this sink. So here we can consider this CaCl2 and MgCl2 as a washing, and this washing is discarded. In this way we can regenerate this sodium zeolite from exhausted zeolite like calcium zeolite and magnesium zeolite. In this way we can use this zeolite softener for the further process of the softening of water. Now the next point is advantages of this method. The residual hardness of this water which obtained from this zeolite method, the residual hardness is only 2 to 10 ppm, means only 2 to 10 ppm hardness remains in water after the softening process. Then second is, the second advantages of this method is a compact in structure. It's a compact in structure. Then we have seen the number of reactions and we have observed that there is no formation of the sludge. So this is the advantages of this method. There is no sludge. there is no sludge formation, and it is automatically adjusts the flow of the water, means the intake of the water. So the intake of the water automatically adjusts in this method. So we can say automatically adjusts the flow of water, the flow of water. So these are some advantages of this zeolite method, and there are some disadvantages also. Disadvantages: from the reactions and from the process, we have observed that the Na plus ions get replaced by Ca2 plus and Mg2 plus, means from the water the Ca2 plus and Mg2 plus combine with the zeolite, and the number of Na plus ions are present in this soft water. So here we can see the more sodium salts, means Na plus ions are present in soft water. Na plus ions are present, Na plus ion in the form of the salt are present in this soft water. Then the next disadvantages is, if we use the turbid water for the softening, so the turbidity blocks the pores which present on the zeolite bed. So for this method we cannot be use the turbid water. Cannot be used. Turbid water. And again from the reaction we have seen that the number of acidic groups lose in water during the reaction. So it lose the acidic ions, in soft water. So these are some disadvantages of zeolite method. So zeolite method is very important because the residual hardness is only 2 to 10 ppm, and this is compact in structure, that's why, and the less supervision is also required. So this method is very useful for the softening purpose. Thank you.